So now that we know all about complex numbers, well, really we don't. There's a lot to know about complex numbers. We've kind of barely scratched the surface. But we know all about what we need to know to add, subtract, multiply, and divide them. And so let's solve some quadratic equations, and the solutions are going to turn out to involve square roots of negative numbers, but we can handle that now. Okay, solve x squared plus 81 equals 0. Since there's an x squared but no x term, I think the easiest way to solve this would be by getting x squared on one side equal to a number on the other side and then taking square roots. So subtract 81 on both sides, x squared equals negative 81. And then remember, for x squared to equal a number, x would equal either the positive or the negative square root of that number. So x equals plus or minus the square root of negative 81. Okay, what is the square root of negative 81? Whenever you see the square root of a negative number, that's when I gets involved. That would be I times the square root of positive 81. I times 9, or just 9i. So our solutions are plus or minus 9i. In other words, x could be 9i, or it could be negative 9i. How about this one? X squared minus 4x plus 5 equals 0. This one looks like a good one to solve by completing the square. You could also do it by the quadratic formula. If you want to try it that way, you're welcome to. But I think I'm going to complete the square here. So I'm going to leave the x squared minus 4x where they are, but get rid of the constant term on the left by subtracting 5 on both sides. Now, to actually complete the square here, to make this a perfect square, the number I have to add on is, remember how to figure that out? Look at the coefficient on x, take half of that number, and square it. So half of minus 4 would be minus 2, and if you square that, you get positive 4. So I'm going to add plus 4 to both sides of this equation. X squared minus 4x plus 4 equals negative 5 plus 4. And then this x squared minus 4x plus 4 is just something squared. It's x minus 2 squared. And the negative 5 plus 4 is negative 1. So now we got something squared equals a number, so the something, x minus 2, equals plus or minus the square root of the number. What is the square root of negative 1? Well, that would just be I. So x minus 2 equals plus or minus I, and that means x would be 2 plus or minus I. So the two solutions to this equation are 2 plus I and 2 minus I. And how about this one? 9x squared plus 12x plus 5 equals 0. And on this one, I think I'm going to use the quadratic formula. So I'm going to take the quadratic formula and I'm going to plug in the numbers 9 for A, 12 for B, and 5 for C. And here they are all positive. So that looks like x equals negative 12 for B, plus or minus the square root of 12 squared minus 4 times 9 times 5, all over 2 times 9. Okay, under the radical sign, 12 squared would be 144, and 4 times 9 times 5 would be 180, and then down on the bottom, 2 times 9 would be 18. When I finish calculating under the square root sign, 144 minus 180 is negative 36. So we're looking at x equals negative 12 plus or minus the square root of negative 36 all over 18. What is the square root of negative 36? I hope you said 6i. So we're looking at negative 12 plus or minus 6I over 18. And that can be simplified because the numerator and the denominator both have a common factor that we can divide out. The greatest common factor is 6. So after we divide out a 6 on top and on the bottom, this reduces to negative 2 plus or minus I over 3. You could leave it like that, or you could break it up into separating the real part and then the imaginary part with the I. So it would be negative 2 over 3 for the real part, and then plus or minus 1 over 3 times I.